Hi guys, Sarmad here again for Millie's Flying Fish sensor implementation and hardware module. I'll get started straight away by showing you guys Millie's Flying Fish. Of course, for this module we have added on our sensor, the MPU 6050, and I've sticky taped that with double-sided sticky tape to the back of the fish. Just because there was more room and just kind of balances the weight a little bit better. If we have a look, the pins that are going through the holes in the MPU 6050, I have soldered them on so that the connection is solid. Then we've got wires running from the MPU 6050 to our Arduino, and of course we still have our servo motor, which is still connected to the Arduino. So that's our hardware and that's all set up. I'm just going to connect that now to our code and show you what data we're getting. Just before I do that, I will show you that we've got our green light here and we've got our green light on our MPU 6050 showing that it's all working. So here's our Arduino code. I shall run through it really quickly and then show you the values that we are getting. So first off, we start by adding in a library, and then we set up the address so the Arduino knows where to send the messages. We also set up 3 containers which will store rotation measurements from each of the axes X, Y, and Z. Then we set up the system at a speed of 115,200. Then we wake up the communication system, we send a wake up message and we tell it the address and yeah, just get it to wake up pretty much. We wait a little bit just to make sure that everything is working for 100 milliseconds, and then we go through the code, and in the code yeah, we just run a loop over and over again continuously. We request 6 bytes of data from the sensor, so that's 2 bytes for each of the 3 rotation directions, X, Y, and Z, and then we print it to our serial monitor. And as you can see here, that data is raw and being printed to our serial monitor. You can also note here that even though our fish is absolutely still, you can see we're still getting measurements in the z-axis of minus 140 approximately on average, and so that's not calibrated, so that's why it's coming out like that. To do our 3 tests, I'm actually going to open up the serial plotter because I think that the serial plotter is a much better way of noticing change in our 3 axis of rotation. So we can see it's coming out constant here because the fish is not moving. For our first test, I'm going to move the fish in this axis, the x-axis, and we can see that the fish clearly, that the output that we're getting from the sensor clearly shows that one of the axes is moving in a wave pattern, and the other 2 are staying constant. Now what I'm going to do is, for the second test, I'm going to move the fish in this axis, trying to keep the x-axis as still as I can, and we can see that the green line, which is the axis that I'm currently moving, stands out more than the other 2. And then for our last test, I'm going to move the fish not this way. I am going to move it this way, and we can see that the orange line, the orange axis, clearly is standing out from the other 2. This wire is making it a bit choppy, and I'm having movement in the other axis, but that's just my own human error, I guess. And now that the fish is stationary, we can see we're getting stationary results from our MPU 6050. But yes, this is our sensor module video for Millie's Flying Fish with raw, uncalibrated data. See you in the next video.